Hello, my name is Yash Arote. So I will be demonstrating my project Elastiviz. Elastiviz is a chat-driven observability visualization system that leverages Elastic's agent behavior. So the flow is that user has some kind of a data in Elastic, suppose data from Kubernetes Elastic agent. Now in Elastiviz, user can input a query like suppose user enters show top 3 pods consuming maximum CPU. So what happens is that leverages the Elastic's agent builder, and that agent builder then returns the rows plus the chart type that needs to be plotted. After that, it runs anomaly detection logic, and then after it shows the UI. The UI shows the appropriate chart, which can be a line chart or a bar chart. That is how it works, and basically converting a user query into the specific visuals that are generated dynamically based on what the user asked for. This uses Elastic Agent Builder. So this is the agent which I have created in the Elasticsearch. It has those tools which it uses to run the operations. Now the difference here is that we are using a tool of type MCP, because the problem is that Elastic's Agent Builder can only be created in a Elasticsearch project, but the Kubernetes events are coming to the observability serverless project. So here we can't create an Elastic agents. What I've done is that agents are all of type MCP. What is happening is that after receiving the tools are calling our MCP endpoints that reside on our server. So basically our server is then running this SQL using the observability's Elastic ESQL query API. So what is happening is that tools that exist on Elastic agent MCP endpoint that resides on a server. Then our server does the part of checking whether the requested entities can be actually mapped or not, or whether. So how the flow is happening is that after the user inputs the query, the server pods endpoint, that is our server endpoint, receives that query, which is then forwarded to the Elastic's agent, which I will show you the agent I have created. So how this actually works is that here the user is requesting show top 3 pods consuming maximum CPU. So this request is forwarded to our server's endpoint. Then the server calls the Elastic's agent builder. So this is the agent. That agent uses 4 tools that I added in the tools section. Using those 4 tools, it is able to construct the specific ESQL query. Is then that ESQL query is then executed, and then it returns the rows and the chart type which is required for plotting the chart. But the problem is that our data resides on observability serverless project. As the Kubernetes events are coming here, we can't have a tool that is of type ESQL, as our events are coming on the observability's serverless project. Observability serverless project doesn't support creating agents, and this is where our data from Elastic agent is coming, that is on the Kubernetes. So what we are doing is that the tools that we created, which are required for executing creating and executing that ESQL. So what is happening is that they are requesting our so what is happening is that the MCP tools that reside on Elasticsearch are again calling the endpoint which resides on our server pod. So this MCP endpoint is then responsible for doing all the actions. So here the run SQL part, which is actually responsible for returning the rows, this is done using the ESQL query API, which queries the observability's Elastic cloud for the data, because the data resides there. So this is something different, as we can't leverage the data because it doesn't reside in the Elasticsearch, it resides in observability. So we are using the ESQL query API. So this is what our application looks like. So this is what I asked for: show top 3 pods consuming maximum CPU for the last 4 days. So it dynamically inferred that we need to plot a bar chart for this, and it accordingly plotted it and explained some of the things about it. So as we can see that it was able to show that the stress pod is consuming the maximum CPU, that is 1.54 cores, and it also has the ability to remember the past query. So if I just say give this for nodes, it automatically comes to know that we are asking for the same thing but for the entity type node. So it gives this for, as we have only one node, so it gives this for minikube, that is our node that is present. We can also have something like show memory usage of pod noisy over last 20 days, but as it didn't have any usage, we can see it is 0. But as it can be seen, this is a line chart, so it automatically returned the type as the line chart because the data was of that type. As above this was an aggregation, so it returned a bar chart. It also has the ability to do this multi-step logic. If I say show CPU usage of top 3 pods over the last 20 days, so it selects the top 3 pods and then plots them. As it can be seen, we can tweak the time windows, and this is a line charts we can maximize. So this is what it returned. So what we are basically doing is that we are generating insights on the go as required, which is I don't think any application is currently trying to solve. So this is what all was about. Thank you.